Today we got 3 sections to cover. Now, chapter 3, with adding in the function one, and it's the longest chapter we have. So what I decided to do is break it up into basically into halves. And so I'm gonna, instead of giving one big test at the end, I'm gonna give 2 shorter tests, and they're each gonna count as like half a test. But we're just gonna do a few sections at a time rather than doing all 7 sections, or 7 or 8, whatever it is. Might even be 9, I don't remember. But instead of doing them all at once, we're gonna do it in halves. Okay. But each test will count like a half a test, and so overall it'll still count as just one test in your semester grade. So having said that, our first half a test, which it'll be shorter, it'll be probably closer to 40 minutes rather than 70 like the last one was. So that'll cover, just it'll cover, and I'll send out an email about this, but it'll cover section 3.1, which it seems like we did forever ago, back in a couple weeks ago, and it'll cover the factoring. And it'll cover the first 2 things we do today, which will be 3.2 and 3.3. Okay, we will cover 3.4 today, but that will be due in the future, right? And that'll be on the next test. So on this test will be 3.1, 3.2, 3.3, and then the factoring. That'll be next week. Like I said, it'll be a little bit shorter test, but 4 today, 3 sections tonight. Yep. I did. And you may not notice this, but at the end of the semester, I cut out, there was a really big chapter at the end also, and I cut out all but 2 of those sections, because really those 2 are the important ones that we really need to get to. The other 3 were kind of just, you could also do it this way, and you could also do it this way, and you could also do it this way, and it was really probably more than what we covered. So I have cut that out, and that's allowing me to kind of cover most of the week's 2 sections at a time rather than 3. So that'll help us out, I think, a little bit with the amount of time. So we're moving on to section 3.2, which is talking about quadratic functions. And quadratic functions, we've already kind of dabbled with them a little bit, in that we were doing factoring last week of quadratics, right? And quadratics are things that have a degree of 2. Their highest power is a 2. So a quadratic function is a polynomial function that has a degree of 2. And it can be written in the form of ax, or f of x equals ax plus bx plus c, which is what we saw last week when we were doing factors, right? Just the ax squared plus bx plus c, that's what we saw last week. And a is not 0. When we think about the graphs of quadratics, they're all different transformations of our toolkit function, y equals x squared. Or f of x equals x squared. And if you remember what that looks like, that's that U shape. It's called a parabola. And so they're all going to have this U shape. They might get moved left and right, or up and down, or stretched and shrunk, or reflected, but they're all going to have this sort of a U shape when we talk about these quadratics. Okay, so let's do an example that is going to lead us to a quadratic situation here. It says a backyard farmer wants to enclose a rectangular space for a new garden. She has purchased 80 feet of wire fencing to enclose 3 sides and will put the 4th side against the backyard fence. Find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have a length of L. So let's see if we can draw a picture of that. See how well these markers work. I just break mine out. So let's see if we can draw a picture. So you've got your backyard, and we're going to start with the backyard fence. So here's our backyard fence. Okay. Now she is building a rectangular garden, and rectangular means kind of what shape? Yeah, it's like square corners, right? Okay. So the idea is here's some sort of a fence that looks kind of like this, right? That's the idea. Now it says the sides of the fencing perpendicular. That's a really big word. What does perpendicular mean? Anybody know? It means it forms a right angle. So we're saying that this side right here and this side right here that are perpendicular to the fence have lengths of L. So this side is L, and this side is L. Okay? Now we have to figure out what that last side is, how long it is. So this is our information. Got 80 total feet of fencing, right? So the L and the other L and the third side all together equal 80. Does that make sense? Okay. So let's take a look at that. Let's call just for a second, let's call this X, and we're going to figure out how long X is, okay? So we know that X plus L is going to equal 80. Okay, when we add up all those three sides. Now, we can combine them. What's L plus L? What do we get when we add things like that? Well, I don't mean a number. I just mean what happens when we add two variables like that together, L plus L. What do we get? That's if you multiply. If we add them, it's 2L. Okay, so L plus L is 2L. And if we want to figure out how long this is and get that X by itself, what are we going to do? How do we get that X by itself? Subtract. Subtract the 2L. So X, that third side, is equal to 80 minus 2L. Now, we can't simplify that at all, but we're going to go ahead and put that on our picture. Okay. Now, we've got our picture set up. Here is the question that we're actually supposed to do. Find a formula for the area of this rectangle. Does anybody remember the formula for how you find area of a rectangle? Or does anybody remember how you find the area of a rectangle? Probably been a long time since you learned those shapes back in like 6th grade or geometry. Say that again. Just two of them. Just length times width, or base times height, however you learned it. So we take this length, which we know is 80 minus 2L, times this height, which we know is L. So area equals the length, 80 minus 2L, times L. Okay. Now, the way this becomes quadratic is we distribute the L. So L times 80 is 80L. And then L times minus 2L is minus 2L squared. So do we see that we get that quadratic now? It's a degree of 2. And so since they asked us to find the formula, we're done at that point. That's the formula. If we find out what L is, we can figure out what the area is. So if we know L is 10, we just plug it in, put it on our calculators, and we figure out what the area is. If we know L is 20, we can figure that out as well. Okay? So on this first one, it was just a matter of realizing that there are situations that if you start working with that and try and figure it out, you're going to get a quadratic situation. So 80L minus 2L squared is your formula for finding the area based on the length of those sides. Fortunately, we don't have to do that too much, but that's how you would do it. Okay, we are going to come back to this one a little bit later, but let's take a look at another one. Let's take a look at some graphs. Are we okay to go on? Okay. I'm going to leave that there because we will be coming back to it. Okay. So this is your parent function. This is your toolkit function, right? The vertex is the point where the function changes direction. In other words, it's decreasing on the left-hand side, and then it stops decreasing and starts increasing. That vertex is, in this case, that very bottom point. Okay, and I marked it with a nice red dot here so you can hopefully see it. Can you see the red dot, hopefully? Like right there is the vertex. Okay, notice where the vertex is? 0, 0. So on your parent function, that vertex is right at 0, 0. Now we can use that. Make sure I'm stopping you from writing. we can use that to help us. Of course, this is in the way now. To help us figure out what's going on with some other functions. Now, this one, we said all of these functions are going to be transformations of that parent function, that toolkit function. So this question asks us to write an equation for the quadratic graph below as a transformation of f of x equals x squared. Then expand the formula and simplify the terms to write the equation in standard form, which is the ax squared plus bx plus c. Okay? Now, we're going to have to think back a little bit because we talked about these a little while ago. When we start moving things left and right and up and down, so we know our parent function is this, f of x equals x squared. Does anybody remember how we moved the graph left and right? Or up and down, I don't care, anything.
And so it's good for us to take the—
Well, let's first of all look at the graph and see where it's been moved. The center, or the vertex, I should say, is normally right there. Okay, it's normally at 0, 0. Where has this vertex been moved? Yeah, now it's here, right? So where did it get moved? It got moved 2 to the left and down 3, right? So that's where it's been moved. So as a refresher, when we move left and right, we're always either adding or subtracting to the x. So what happens is it's going to look like this. Let's call this g of x. So g of x. Oh, it's even labeled g of x. I guess we have to call it that. So we're going to have the x, and it's still squared, but now we're going to do something to the x. Does anybody remember how we make this move 2 to the left? It is plus 2, because remember, it always works backwards inside with the x. So the way we move to the left is plus 2 inside there. How do we make it go down 3? Minus 3 at the end, on the outside. Okay? So that's the beginning. The problem is, this one hasn't just been moved over and down. They also changed its shape just a little bit. Not much, but just a little bit. So here's how we can figure out how they did that. And the other point, when you change the shape, you're stretching it or shrinking it. And there's this a value in the front. Let's use a different color. There's this a value in the front that is in charge of stretching and shrinking. Okay, so here's how we do this. And you may remember this. We talked about this a couple weeks ago. If you want to figure out a missing value in your equation, you take any point on the graph and you plug it in. So probably the easiest point to choose is going to be this point right here. What's the coordinate for that point right there?
Sometimes in our desire for over-simplification,
0, negative 1. Perfect. Okay, so that means x is 0 and y is negative 1, right? So what we can do is we can plug this in. Y, this is like the y, so negative 1 equals a, and we just said x is 0. Okay? So if we simplify this, what is 0 plus 2? This is the one you guys all like, right? 0 plus 2 is 2. And then we square it, so that makes 4. And then we subtract 3. So what is that? 1. All right? Something's wrong here.
It's across the board. It's not just people that are in poor areas. In fact, they're not hired. For example,
oh, duh. Okay, sorry. Temporary insanity. The 4 is multiplied by the a, right? So, and this is a mistake I tell my students all the time not to make, and I just did it. So the 4 is multiplied by the a. We can't subtract the 3 from it because it's connected to the a. It's actually 4a. So what we have to do to get this a by itself is, first thing, we have to, how do we get rid of this minus 3? Plus 3.
That is the joint highest.
So now this is a 2, and I'm going to rewrite this. A times 4 is just 4a, right? And then what else are we going to do? Divide by the 4. Now be careful. What does that mean that a is? 2 divided by 4? A half? So that means our equation, if we go back to here, our equation is g of x equals 1/2, then x plus 2 squared minus 3. Now that is in our, what we're going to call our transformation, or what we call vertex form, because we can look at it, we can see where the vertex got moved, and we can see all the different transformations that happened to it. But the last thing that they asked us to do is to actually multiply this out and put it in standard form. Okay? So is it okay if I erase this? Does anybody need that to stay there right now?
What are some issues within this whole aspect of family violence? First of all, family abuse and parental rights.
All right, so what we're going to do,
I really want to get your
x plus 2 squared means x plus 2 times x plus 2. And then we still have the minus 3 at the end. We do this multiplying first, and you remember we have to distribute.
What I mean by parental rights.
So x times x is
Legally,
x. When you multiply them together, you get x squared. Then x times 2 is just 2x. 2 times x is 2x again. And 2 times 2 is 4.
we don't really have too much of a.
Okay. Then we want to distribute this 1/2 to each thing in here. And some of them are easy and some of them are not quite so easy. So 1/2 times x squared is just 1/2 x squared. What's 1/2 times 2x? What's half of 2? 1. So plus 1x. And then we do the same thing again, right? 1/2 times 2 again. And then what's 1/2 times 4? Which just means what's half of 4? 2. Okay, so then our answer is we're just going to combine the like terms, 1/2 x squared. We add these two together, we get 2x. And we add these two together, we get minus 1. So this right here is our answer in standard form. Okay.
And legally, it's extremely.
The key thing that we're actually doing there, I'm not as worried about this part, but the key thing is being able to see that transformation, moving 2 to the left and 3 down. Okay. So that one took a little bit of space. But that's our answer when we put it in standard form. So we're going to be looking at standard form. We're going to be looking at what we call typically vertex form. And we're going to be comparing those two because they're really saying the same thing, but it looks a little bit different when we see it. Okay? Anybody need more time to write that down?
All
right. Okay. So standard form is the one we've been talking about. F of x equals ax squared plus bx plus c. Right? That's the one we saw last week when we were factoring. That's called standard form. And we're going to put these in one of two forms, either standard form or the next one, which the book initially calls transformation form, but then it goes on and it calls it vertex form. Typically, we call it vertex form, so that's how I'm going to refer to it. And vertex form is the one that shows us that the vertex got moved h spaces, either left or right, and then k spaces, either up or down. Okay? Oh, I just realized there's a typo here. Hang on. So this should be a minus. Sorry about that. That should be a minus. X minus h. Because remember, it works backwards. So in order to move it h spaces to the right, it's going to be x minus h.
And usually it seems always
okay, and then the h comma k, as you can see here, is going to be the vertex of our parabola. That's where it's been moved. Okay, And that's kind of what we're going to be focusing on for the remainder of section 2.3 is that vertex and what's important about that vertex and being able to find it and what it means for us.
Where the body
Okay?
becomes so hateful that mommy or daddy does this to me that they don't know. And they have an affiliation.
All right, are we okay to go on?
There's a strong emotional reason.
We still got some writing going on.
Most abuse is.
Okay. So now, how do we? So one of the key questions that we have is, how do we find the vertex if it's in standard form? Because if it's in vertex form, we just look and we can find the vertex. But what if it's in standard form? And so here are two little formulas. Really, the first one's the only one you need to know. So focus on the first one that are going to help us find the vertex. The way we find that h value, the left and right, if it's in standard form, is we always take the opposite of, or a negative, and then the b value, like we talked about last week when we were factoring, the b is that middle value, divided by 2 times the a value. So this right here, and I'll show you how this works, but it's going to be a negative, and then b divided by 2a, 2 times a. That's how we find the h value. And then once we know the h value, we just plug it in to the function to get the k value. So that's what the second part is saying. It's f of h. It's really not necessary to memorize that as long as you realize once you know the first one, you just plug it in to find the second. Okay. So let's go ahead and let's do this first one. So this is given to us in standard form. 2x squared. Oh, I'm missing an equal sign. Equals 2x squared minus 6x plus 7. And then we're going to rewrite it into vertex form or transformation form. Okay, so the first thing we want to do is find the vertex from this. Our formula, h equals opposite of b over 2a. Right, that's what we just had on the previous slide. We're just going to be using that. I'm going to ask you right up here, what is the a value from our standard form? Remember from last week, we did a times c. What's the a value? It's the 2. It's the first one. What's the b value? -6. And the c value, which we don't need right now, but it's 7. Right? They just go in order. So a is the squared one, b is the one by the x, and c is the one all by itself. So h is going to be a negative, and then b, -6, divided by 2 times a. Okay. Now these two negatives go together and make that positive. So now we have 6 divided by 2 times 2 is 4. And if we reduce that, what is 6 divided by 4? What are they both divisible by? 2. So it's going to be, when we divide them both by 2, we get 3/2. Okay, so that's the h value. In other words, in our vertex, 3/2 is the h value. Now, I just mentioned earlier, once we know the h value, we just plug it in to find the k value. So we're going to go back to this function right here. And we know that k is going to be equal to 2 times our input value minus 6 times our input value plus 7. And what are we supposed to use as our input value? The 3/2. Okay, we're going to plug that in for all those x's. So 3/2, 3/2. Now this is where you may want to have your calculator out because it might make the work a little bit easier. I don't have a calculator with me right this second, so I will do some of these here. This is going to be 2 times 9 over 4. This is going to be 9. And then that's going to be 9 over 2.
There are some guidelines in the religious text of Christianity about not being angry and those.
And I think we get 23 over 2. Is that what you guys are getting, like 11 and a half or something like that? Anybody got their calculator that's actually doing it to test me out? Because, oh no, that's not right.
Or your PC goes to anger, the correct form, that's not good, but
5/2, I think. 2.5. Is that right? Come on, somebody help me out. I see a couple calculators. I know you can use them. So 4.5, that'd be -4.5. Yeah, 2.5, I think, is what we've got there. Or 2.5, however you want to write that. Now I'll let you double check. Since now we've got some calculators out, we're going to be good. Anyone? Yes? No? Yes? Okay, good. Whew, finally. All right. So, and I'm just going to actually write it as 5/2 because that's kind of how we have this one. So that's our vertex. It got moved 3/2 units to the right and up 5/2, which is 1.5 and 2.5. So when we write our answer, remember our vertex form is f of x equals a x minus h squared plus k, right? That's just the standard form. The nice thing is, you know how we had to figure out a before? We don't have to figure out a. We already know a from the very beginning. A is 2. So we're going to have f of x equals 2. And then x minus the h value, 3/2, squared plus the k value, 5/2. And that is that equation rearranged into vertex or transformation form.
So the way it's supposed to work is if the time comes to you,
So again, there's really 2 steps. And like I said, I showed a lot of work that you guys can just put into a calculator. You have to do it without, you can just type it into a calculator. But the 2 steps are right here. Step 1, figure out what h is. And then step 2, plug that in to figure out what k is. And once you know that, you know a from the very beginning, you know h, and you know k, you just plug them in into these 3 spots. Okay? Yeah. No, there's.
We'll go back to the second section. I think it.
Right here?
Yes.
Okay.
You lost me at the second section.
Right here. Okay. So that's just, I multiplied these 2 together. Like I said, you can just take it and type it into a calculator all at one time. Okay? But 3/2 times 6 is 9. So that's all I was doing. I was just trying to simplify it, and I didn't have a calculator. But so you can just take that whole thing and type it all into a calculator all at one time and go straight from here all the way down to here without having to do all those in-between steps. I just, like I said, I didn't have a calculator here, so. What's that?
The 2 times 9/4, the step before that.
Yeah.
How'd you get
if people go ahead and manage
The step, okay, wait a second.
So it's 2 parentheses 9.
Here, okay? We did 3/2 squared. Does that first one get squared? So 3/2 times 3/2 gives you 3 times 3 on the top is 9. 2 times 2 on the bottom is 4. So, yep, and that gets multiplied by 2. So 2 times 9/4 is actually 9/2. Again, you don't have to worry about all these steps. If you've got a calculator, just type it into the calculator, and it will give you straight to that answer of 2.5.
So the first step is to figure out what h is.
First step is figure out what h is.
And then the second step.
It's just plug it in and type it in. You don't have to make it hard. Just type it into your calculator and get that. I just don't have a calculator sitting up here. If I did, you'd see me doing. But you guys need to practice putting that into your calculator. But if you type this right here into your calculator, well, not the k part, but the other stuff, you should get 2.5 or 5/2 or 2. I mean, it may say it as a decimal, it may say it as a fraction, it may say it as a mixed number. Who knows? Okay. So there's really 2 steps, and then once you know the h from step 1 and the k from step 2, you already knew the a from the very beginning because it's in the first equation, and then you just plug them into those 3 spots. Okay. But like I say, don't let this scare you. This is just because I don't have a calculator here. right? Were you able to type it into your calculator and get the 2.5? Okay, so that's all you have to do. You just type it in. Okay. All right.
The person gives their testimony on video or television. Because the person seeing.
Now we are back to our backyard garden example here. So our farmer wants to find the dimensions that make her garden as big as possible. So what size should she make her garden? Well, here's where finding that vertex is important to us. Because if you remember where the vertex was, it was right here at the bottom, right? Does that make sense? That's where the vertex was. Now, if our parabola opens down and has been reflected, the vertex will be right here at the very top. Does that make sense? So the vertex is always the either very, very highest or very, very lowest point on the graph. Okay? So if we want to find a maximum, which means the biggest, or if we want to find a minimum, which means the lowest, we're going to look at the vertex, because the vertex will give us the answer. So that's what we're going to do for this example right here. Notice we probably want to put this in the right order that we would normally see it, because we would put the squared term first, so minus 2L squared plus the 80L. And then there's, if you want to put it there, there's just 0 at the end. Okay. So we're actually going to do the same thing we just did, but we don't care about the equation. We just want the numbers, the h and the k this time. So let's start out by, what is the a value here? The -2 is the a value, the one by the L squared or the x squared or whatever's being squared. So this is our a value, -2. What's the b value?
Or find if they are 2010, that's a lot of
80.
figures that we've got.
And that's this one by the L. And then the c value, even though we don't need it right now, is 0. If there's nothing there, it's automatically a 0. Now, what was the little formula we have to use to help us find the h value?
It was
Negative b over 2 times a. So we know that we've got a negative, and what did we say the b value was? 80. And then what do we know about the, we got the 2, and what's the a value? -2. So once again, we actually have these two negatives, right? And they're going to cancel out, become positive. And then, now I will say, if you're using a calculator, you do have to be a little bit careful here. Simplify the bottom before you try and do it all in a calculator. What is 2 times 2? 4. Okay, then you're great to go use your calculator. What is 80 divided by 4? 20. So our h value is 20, right?
Of those in terms of gender, slightly more were girls and boys.
Now, once we know that that is 20, what do we do to find the k value or the other value? We plug it back in. We enter it in. That's right. So k is going to be 80. Well, I guess we rearranged it. So -2 times L squared plus 80 times L. And what are we putting in for the L? 20. So again, at this point, just go ahead and type it into your calculator. I'll try and think about what it's going to be, see if I can figure it out in my head, but I don't want to make it, that seem to scare people. You don't have to worry about doing all that work. Just type it into a calculator.
This is a simple chart for you to be able to see.
If you, who said that? You type it in right? I think it should be.
And then you've got the next is 7, and then it goes down as they get 800 older. So So younger children.
Yes, I think that's right. Were you guys able to get 800? I'm glad you're typing in the calculator because in my head it wasn't going very well. So 800. Okay. Now here's what that tells us. This is HK, but remember the first value is usually X. We've got X and Y, but in this case, the variable we're using is L and A. So we're saying, the question is what dimensions? We're saying L should be 20. Right, 20 feet? And remember our picture, I had to erase it, but here's what the picture looked like. We had L, and then 80 minus 2L. So in other words, this side is 20, and this side is 20. And if you remember, we had 80 total feet of fencing. So if we use 20 here and 20 here, how much do we have left for the top? 40? So your dimensions are going to be 20 feet. I should put feet here. By 40 feet. So the two sides are 20, and the top is 40. And that would give them the biggest area. And that's what this is. This is actually the biggest area you could have using that fencing.
That's the answer.
The 20 by 40 is our answer. Because that's what they asked for was the dimensions. But just some extra information that we get automatically is what would that area be? And that's the 800. What? A parallel? A parallel what?
Wasn't there one of the?
Are you talking about equations of lines now? Well, this is not like.
Well, I did it yesterday by accident, and there was one of the square.
Like this?
Non-parental perpetrators.
I'll have to look at it. See if you can find it and then show it. I don't know. Did you bring your computer? Okay. During break, pull it up and we'll take a look. Okay. So the first one really in this case was all we needed, but sometimes you want that. So here's what the first one tells us. What value will give us the maximum? In other words, if L is 20, we're going to get the maximum. The second number tells us what the actual maximum is. Or vice versa. If it's a minimum, it tells us when we'll get the minimum and what the actual minimum is. Okay? So here we go. You like the answers, so we're going to put the answers. There we go. The length is 20 feet. The width would be 40 feet. And that's going to give us the most area in our garden. So we can make the most, grow the most, I don't know, whatever you like to grow in your garden. I like to grow green beans and corn in my garden, but sometimes spinach. All right, we're done with that one now. Okay? So we have three different cases that can happen when we think about a parabola and the x-axis. One option is this parabola might be completely above, or it could also be completely below the x-axis, where it never crosses the x-axis, and so it would have 0 x-intercepts. Remember, an x-intercept is where it crosses the x-axis. So if it doesn't ever touch that, there's 0. Okay? Another case is where it just comes and just barely touches the x-axis in one spot. In other words, at its vertex, it just comes down and touches the x-axis and then goes back. So it could have possibly one x-intercept or horizontal intercept, since it's the horizontal axis. Or if you move that parabola down a little bit further, we could possibly have 2 x-intercepts. Now, no matter how much further we move it down, you're still going to only have 2 x-intercepts, right? Because it's not all curvy, it can only have 2. It's never going to hit 3 times, or 4 times, or anything else. You can only have 0, or 1, or 2.
But there's also psychological.
Okay. Did those pictures make sense? And again, we're looking at where does it cross the x-axis. So none, it doesn't cross at all. Here it just touches 1 time, and here it touches twice. In this case, at 1 and 3. So those are our x-intercepts. And how many we can have. So we want to find those. If we have an equation, can we find the x-intercepts? So here's what we want to remember. If you look back at our x-intercepts, What's the coordinate of this point right here? The XY coordinate?
Obviously, there's the
2, 0. What's the coordinate of this point? This one? 1, 0. And this one?
without
3, 0. Remember, the x-intercept always has a 0 for the y value. That's how we find it. Okay? We did that, I think, a couple weeks ago also. So anytime you're finding an x-intercept, the y value is going to be 0. So when we go to this, and we want to find both the x and the y-intercepts, the vertical and horizontal, let's go ahead and do the horizontal one first, or the x-intercepts. So we want to replace this, which is like in the place of y, we want to put in a 0. Okay? Now, if this looks similar to last week, it should, because we did this right at the end of class last week. We factored and then solved, and you had some on your homework, and most of you guys did really, really well on this. I don't know if it took you several tries in the practice, but most of you did really, really well on this. So what do we have to do to try to factor this? Who remembers from last week?
not only on the television.
I'll jump at once. Okay, well, I'll remind you one time here. The first step is we multiply A times C. Right? 3 times the negative 2. It gives us negative 6. And it has to, so we've got to find factors of negative 6. Now again, since this 6 is negative, what does that tell us about the signs of the numbers we're going to look for?
Negative.
Well, even before that, it tells us they're different. I mean, you're right, but it tells us they're different, right? Because when you multiply two numbers together and you get a negative answer, one has to be positive and one has to be negative. So it tells us that one of them is positive and one is negative. Okay? Here's green. So then we look at this one, and what does that tell us? Since they have to add up to be a positive, and they have different signs, this tells us the bigger one is positive. Okay, so I'm going to circle that. The bigger one is positive. And then remember what we do? We just start writing down the factors. What are the factors of negative 6 where the bigger one's positive? Well, we could have negative 1 and 6. And actually, that's it. That first one is the 1. Because negative 1 plus 6 gives you 5. Okay. Now I've reminded you a little bit, but does anybody remember what we have to do next? We've got to rewrite this, and we replace the 5 with those two numbers. So 3x squared and minus 1x and plus 6x minus 2. Remember that these two together equal to 5x. That's why we can do it. And then do you remember what we do? Yes, perfect. Whoever said it, perfect. We group them. Okay. What can we take out of that first group? An x, and then we still have a 3x and a minus 1 left. Okay. Then we have to take out the plus sign. What else can we take out of the second group? 2. And we're dividing by a 2, so 6x divided by 2 is 3x. And negative 2 divided by 2 is negative 1. And again, if you remember, if we do this correctly, those two should be the same, right? So that means one of our factors is that 3x minus 1. We're going to take that out. Then what do we have left here is an x and a plus 2.
7.5 million children involved, and 5 children die every day.
All right. Now this was the very last thing we did last week. What do we do after we have this factor?
This says that 75%, 80%.
We set each factor equal to 0. So we're going to have
And
3x minus 1 equals 0, because if that's 0, it makes the whole thing 0. And x plus 2 equals 0, because if that's 0, it makes the whole thing 0. Now this is the easy one.
And so.
What do we do to get that answer? Subtract 2, so we get x equals -2. So that's one of our answers. What do we do to this one? We have 2 steps here. Add 1, so 3x equals 1. And then we divide, and we get x equals 1/3. Now, these are our x-intercepts. So our x-intercepts are, remember how they're ordered pair because they're points on the graph? X is 1/3. What do we know y is automatically? 0. And then the other one, x is -2. And y is automatically 0. So that's the horizontal. Those are the x-intercepts. We did the hard one first. Because do you remember what happens, how we find the y-intercept? Remember, for the x-intercept, y equals 0. For the y-intercept, x equals 0. So this one's much faster. We do, and I'm just going to say y, but 3 times 0 squared plus 5 times 0 minus 2. And again, you can use a calculator if you want, but 0 squared is 0. This is the vertical one. 0 squared is 0. And 3 times 0 is 0. And then 5 times 0 is 0. And then minus 2. So we've got 0 minus 2 is -2. Right? That's the easy one. So that means x is 0, y is -2. So there's the y-intercept. These are the 2 x-intercepts. Y-intercepts are easy. You just put in 0. The x-intercepts are the ones that usually take some work. Unless they're factored for us already, and then they don't take nearly as much work. Okay, so that's why we had to do the factoring last week, because otherwise we wouldn't have known how to do that. Right? So does that make sense? Do we remember kind of the factoring that we did last week? Like I said, most of you did pretty well on your homework on it. And you maybe spent a lot of time on it, but you guys did a really good job on that. So hopefully we kind of remember that a little bit. But that's how we find x-intercepts and y-intercepts. For x-intercepts, you put in 0 for the y. For y-intercepts, you put in 0 for the x. And it always is that way, no matter what kind of graph you're talking about. Okay? Any questions on that before we go on?
It's always right.
All right. So there's our answer, the 1/3 0 and the -2 0, and then the 0 -2. So we got that taken care of. All right. Our last main big topic for quadratic functions is the quadratic formula. And you may or may not have seen this before. Those of you who are in my class, I know you've seen this before. Okay. But it's just, it looks complicated, but it's right here. X equals opposite of b plus or minus square root of b squared minus 4ac over 2a. And again, a lot of this you'll be able to do with a calculator, but certain parts you got to kind of do by hand. So we'll take a look at that. But the quadratic formula can be used when your function is in standard form. It has to be in standard form in order to use the quadratic formula, because you need to be able to figure out what a is and what b is and what c is. And what it says is it gives the horizontal intercepts, it gives the zeros, or gives the x-intercepts. That's what we found with factoring on the previous example.
On a typical day, 20,000 phone calls are placed for domestic violence.
Okay, everybody have that written down? We're going to use this a decent amount here, so we want to make sure we got it. Everybody got it?
I don't know about you. Desperate enough to call domestic.
I feel bad. I have people sitting in the back and then they squint like, I can't see it. All right, are we good? Okay, so let's find the horizontal intercepts of the quadratic function right here. Now I'll tell you this one. We could try to factor it, but there are some things, I don't know if you saw this on your homework, but there are certain things that don't factor and they're called prime. I think most of us had at least one on our homework that was like that, where it was prime and it didn't factor. So we could write down all those possibilities and none of them worked, and that means it's prime. Okay? So this is one of those where we can list them all out and it ends up being prime and it won't work out for us. So when it doesn't factor, we can use the quadratic formula. So here's how the quadratic formula works. I would suggest always identify A, B, and C first, because that's what you're going to plug into your quadratic formula. So what is the A value here? 2. What is the B value? 4. And the C value? -4. Right? So A, B, and C. So identify those first, because that's what we're going to plug in. So I'm going to start right here. Whoops. X equals. And I'm just going to write this down. You guys have it on your paper, but it's the opposite of B, plus or minus, square root of B squared minus 4AC. And then underneath, you got 2A. Okay? Now, all we're going to do at the beginning is plug in the numbers. We're not going to do any math right now. We're just going to plug in the numbers. So we have the opposite of, what do we put in for the B? 4. So opposite of 4, plus or minus. Then inside we have B squared. So we're going to write 4 squared. And again, I usually use parentheses here. It'll help your calculator not make mistakes for you. So if you use parentheses there, that'd be a really good idea. And then minus 4 times, and again, I usually use parentheses. What is our A value? 2. And so we put that in there. And our C value? -4. Over. And then we've got 2 times A, and that is 2 times, what's our A value? 2. So notice we didn't do any math. We just plugged in the numbers, right? Okay, so let's do some simplifying. Can I do anything with -4? No, -4 is just -4. So we're going to write that down. Now, this stuff in here, use the parentheses, but you can type all of that into your calculator all at one time, all the inside. Don't type in the radical, but just the inside part, the 4 squared minus 4 times 2 times -4. And let me know what you get. Let's see if I can figure it out. Got 48. So 4 squared minus 4 times 2 times -4. And I think 48, did you get 48 also? Okay. I'm getting a squint, so that means we didn't get 48 on that one. Yeah. Yes.
If it was the opposite, like -4.
Yeah.
Would it be positive?
It turns into a positive. Yep. So if you have the negative in the front and then a negative number, yeah, it's going to turn into a positive. Can I take one that you typed in? Oh, okay, okay. This is a calculator, you can't type it all at one time. So you'll have to do it part of the time. So you know that 4 squared is 16, right? And then you can get those other ones together. So you can do -4 times 2 times -4. And you get 32, and then you got 16 at the front plus the 32 at the end. That's it. So yeah, certain calculators will, you can do it all at once, and then certain ones you have to do a piece at a time. So that's where you just got to know how to use your calculator, and that will help out. Okay, so we get a 48 in here. And then in our denominator, 2 times 2, we can all do that, I think, in our heads, that is 4. Okay. Okay, I just realized we haven't talked about this before, but okay. How do we want to do this? Okay, so we got to simplify this radical. Okay, and some of you, again, I know have seen this, and some of you have not. So here's what we're going to do to simplify the radical. I'm just going to teach it. We're going to use something called the jailbreak method. And we're not actually breaking out of jail, but we're breaking the 48 or parts of the 48 out of the radical. It feels like it's in jail, so it wants to escape. So here's how we do this with the jailbreak method. We start with the 48, and we break it up using prime factors. So what 2 things can we think of that multiply together to equal 48? And it doesn't matter what we start with as long as they multiply to be 48. So can you think of 2 things that multiply together to be 48? 24 and 2, right? You can use 24 and 2. 6 and 8 are the other two. But let's start with 24 and 2. Because as long as 2 goes in there, you know, if it's even, we know 2 works. So let's just use 2 again, because that's done. But this can break up into 2 and 12. And then 2 is done again. And this can break up into 2 and 6. And then this can break up into 2 and 3. Okay, so we've got it all broken up. So here's what happens. All these end numbers right here are inside this radical, right? 2, so we just found out 2 times 2 times 2 times 2 times 3. That equals the 48. We just broke it all down into little pieces. Does that make sense? If you multiply 2 times 2 times 2 times 2 times 3, that equals 48. So we just broke it up. Now, the jailbreak method tells us that if we can get a pair of friends and they work together, they can get out. Okay, so notice we got a pair of 2s. That can get out. We also have another pair of 2s. That can get out. The 3 doesn't have a friend. He stays stuck where he is. Maybe we should call it a hole rather than a jailbreak. They're stuck in a hole. You got 2 of them, they can get out. Okay? So what happens is, you got the -4, plus or minus. So this 2 got out. Now the problem is, when they get out, for some reason, one of them disappears. Okay? So this pair will give us a 2 outside. This pair will give us another 2 outside. And then we've got the 3 on the inside still. Okay? So for each pair, only one makes it out. The other one vanishes. I don't know. Disappears. So let's keep simplifying a little bit more. What is 2 times 2? 4, right? Now here's the part that, again, can be a little bit tricky for some people. This 4 on the bottom is dividing the whole thing, right? It's dividing the whole thing by 4. So what we're going to do is we're going to break it up, because that 4 goes under both parts. But we want to kind of deal with that as separate parts. So does it make sense the 4 goes under both parts? So then we reduce each little part. What is -4 divided by 4?
They did it because they stored on the movie. So,
-1. And then we've got this plus or minus. And that's just from the formula still. And then notice right here, you've got this 4 divided by 4. And we kind of treat this separately. So 4 divided by 4 is 1. And then the square root of 3 just stays there. Now we don't really need the 1, because 1 times the square root of 3 is just going to be the square root of 3. Just like 1 times 5 is 5, or 1 times 2 is 2. So here's what this means. We're done, except we want to write down our answer. So we're finding the horizontal intercepts. One of the intercepts is -1 plus the square root of 3, and then the y value is 0. Right? That's what we did way back at the beginning. We put in a 0 for the y. The other one is -1 minus the square root of 3, comma 0. Now the reason we have those 2 is because of that plus or minus right here. That tells us we're going to add it, and then we're also going to subtract it. That gives us 2 different answers. Okay? And again, that just comes from the formula. And so those are our 2 horizontal intercepts. So the quadratic formula is really repetitive, to be honest, because you always do it the same way. Identify A, B, and C, plug it in, and simplify. Now, the simplifying can sometimes be really easy, and sometimes it takes a little bit longer, but you always do the same thing. Find A, B, and C, plug it in, simplify. Find A, B, and C, plug it in, simplify. Find A, B, and C, plug it in, simplify. So it's always the same thing. Oops. Okay, so we've seen one example of the quadratic formula. We're going to do some more, but we've seen one example of it. We got our answers, and what we want to do is do another one. This one's a word problem one. Everybody's favorite. I found out pretty quickly that everybody's favorite on the test was the word problem. I'm being sarcastic, by the way.
1 in 4, 1 in 7, severe physical violence.
Okay, so let's see if we can do this one.
Things like feeding.
This actually combines two things that we've talked about tonight, so let's see if we can figure it out. A ball is thrown upwards from the top of a 40-foot tall building at a speed of 80 feet per second. That really doesn't matter, but that's what they're telling us. The height above the ground can be modeled by this equation. That's the important part. Here's the equation. What is the maximum height of the ball? Okay, so think about this. Do we see that this is a quadratic, which means it's a parabola shape? Okay, because of the negative, it opens down, right? It's been reflected, so normally it would open up, but the negative makes it open down. So it's going to have a highest point, and where does that highest point occur? What's that special name of that point that's at the very top or the very bottom, depending on which one it is? It is starts with a V, the vertex, okay? So we want to find the vertex. That's our first part here for part A. First part. Remember how we find the vertex? It's the H comma K, and you're right. The H is negative B over 2A. Okay, so what is the A value? Negative 16. I'll put that right here. The B value? 80. And the C value in this case is 40. Okay? So let's plug it in. Whoops. We've got our negative here. And the B value is 80. And then underneath we've got 2 times A. What's our A value? Negative 16. So again, as long as you have these two negatives and they're multiplied, they're going to end up canceling out. Okay, so the negatives are going to turn to positives. We've got 80 on the top. We've got 2 times 16, which is 32 on the bottom. And what do we get when we take 80 divided by 32? And you can give me the decimal number. That's fine for this problem. No. 2.5? Oh, that's easy. Okay, so that's the H value, right? So that's when that maximum occurs. When we plug it in, we're going to find out actually what the maximum is. That's the K value. So to find K, remember we just plug it in. So K is going to be negative 16 times 2.5 squared, T squared, plus 80 times the 2.5, and then plus 40. Again, with that, you just, okay, now, okay. So if you've got a calculator, can I borrow yours for a second? If you've got a calculator that looks like this, or some other ones, you'll just be able to type this all in at one time and get an answer. Okay? We found out if you've got one back there, you probably want to do it one piece at a time. Okay? So like Araceli, if you do yours, you can do this part. You should be able to do that part, I think, all at once, like each chunk, one at a time. I'm not sure, but I want to double check before I tell you that. Can you tell me what you get when you type in times
using isolation,
no. Yeah, just you should be able to
controlling what you're looking at in your phone,
yeah, negative 100. Just the first one. Just the first one. Yep. So I think you get negative 100 there. And then go ahead and do the next part. What's 80 times 2.5? Are you going to steal her calculator? What's the second part then? 80 times 2.5? I think that's 200. Okay. And then plus 40, right? And then you'll be able to add them all together and you'll get, what'd you say you got, 140? Okay, so that's the K value. That right there is the maximum. That's how high it gets. It gets up to 140 feet in the air. You didn't get the 140? Okay. Yeah, it's tough when your calculator doesn't cooperate with you, right? Come on, calculator, do what I want you to do. Okay, so we get 2.5 is the amount of time that has gone by, but the 140 is how high that thing gets. That's the maximum height. Okay, so that's the answer to this question, 140 feet. From there, that's the K value. Okay. Okay, ignore that. 140 feet. Sorry, typos. Okay. Now, the second part of the question is, when does the ball hit the ground? Okay, now here's what we have to think of. What is the height going to be when the ball hits the ground? It's not a trick question. What is the height going to be when the ball hits the ground? 0. Perfect. Height's going to be 0, right? It wasn't a trick question. I didn't mean for it to be a trick question. But that means we're going to have 0 equals negative 16t squared plus 80t plus 40. Right? Do you see how that's what we just did? We're finding the x-intercepts when it's going to hit at 0. Okay? So now we're going to use that second piece that we just talked about, the quadratic formula. Okay? So let's identify. We've still got A, B, and C right here, right? They haven't changed. So we're just going to plug them in. So let's see if we can do this. Opposite of B plus or minus the square root of B squared minus 4AC over 2A. So we want to plug it in. We've got a negative, and what is our B value? 80. Plus or minus the B squared, which we just said that was 80. So 80 squared minus 4 times A, which is negative 16, times C, which is 40. Over 2 times A, 2 times negative 16. Okay? Negative 32 is going to be the bottom, so that one we can do pretty easily. Just 2 times negative 16, so that's negative 32. Now, inside the radical, again, if you certain calculators, you can just type the whole thing in. Certain ones you'll have to do a piece at a time. Okay? This happens in my classes at school all the time too. I've got some that just get to type it in and some that have to like work through it and make sure that's right. So if we do the 80 squared, that should come out to be that 6,400 for the 80 squared part. And then these two together, that's going to end up being plus because you got 2 negatives. And then I don't know what this is. Let me think. I may know. Is it 2,560? I don't know. What is this part? Is that what it is? Oh, good. For just the second part? Just the second part? Okay. Okay, and then we would add those together and we get 8,960, it looks like. Is that the whole inside? Okay, were you able to get that? Okay, it just takes an extra step or two, so. Okay. Let's see. What are we going to do here? Man, we got to break up 8,960. Here's what we're going to do. We're going to cheat a little bit because if we're actually wondering where it is going to hit the ground, do we want an answer that looks like the square root of 17 or something like that? Does that tell you anything, really? Anybody know what the square root of 17 is? Just off the top of your head without using a calculator? No, we wouldn't. So probably a decimal answer in this case is a better solution. So here's what we've got. We've got negative 80 plus square root of 8,960. And then we're going to divide by negative 32. And then we've got negative 80 minus the square root of 8,960 divided by negative 32. Now here's where you have to be really careful. Okay? Do the top first and then do the bottom. Don't try to do them all at once or you'll get messed up. I can just about promise you. Okay? So can somebody figure out what is negative 80 plus that? Square root of 8,960. I should get my phone. I can use my phone as a calculator. Oops. Oh, whoops. Okay, forget that. Anybody got it? No? All right, now I got to try it.
So what did you say?
It's just the top part, negative 80 plus the square root of 8,960. And I'm getting about, it's going to be rounded off. It's a decimal. 14.657. Okay. Now, then we do, you did not get that? Okay. Here's what you're going to have to do on yours probably. You're going to have to do this part first. Just type in square root of 8,960. Or I think you have to do 8,960 and then the square root button. And then add a negative 80. Okay. So yeah, you have to do it backwards, unfortunately. So now when we divide this, what will our answer be? Negative something, right? Are we going to go back in time? No, that's like the ball got thrown, and that's like if the parabola kept going down on the backside. So that's not our answer. We're going to get rid of this one. So this is the one we want. So we got to do the same thing, but what's negative 80 minus the square root of 8,960? One more time. 174.657. But it's negative, right?
Yes.
Okay. And then we divide by negative 32. And what do we get? Okay, now remember what that is? That is the x value, or in our case, the t value. So that's saying, when does the ball hit the ground? After about 5.5 seconds. Does that make sense? After about 5.5 seconds? Did you not get that? Okay. So after about 5.5 seconds is when that ball hits the ground, and that is, again, those are the two things we did today. Those were finding the vertex, and what does that mean? Maximum, minimum, and that is finding x-intercepts. What does that mean? It means that it's a 0. So that is the two things applied in a word problem here. Which, like I said, I know everybody loves word problems. So hey, look at that. We even got the right answer. 5.458 seconds. Okay. So notice I didn't give you very many problems on this one. There's only 6 problems. You get some of them might have like 2 points because there may be 2 answers. So, but yeah, anything that's extra up, you'll get 3 points on. So.